We are ready.
Good morning, everyone. I'd like to introduce Andrew Hopkins. He's the keynote speaker today to talk about privacy chain in healthcare. So thank you, Andrew. Appreciate the time. And we're looking forward to a great conversation today with respect to privacy chain, as well as what its implication in healthcare space.
No, thank you, Khalil. It's good to be here. I appreciate the opportunity, and it's good to meet everybody. And it says that I'm info. It says that I'm info at Evergreen NFT instead of Andrew Hopkins, but it's me, Andrew Hopkins. Info Evergreen NFT is another company name that we have.
Yeah, Andrew, you want to start? Take the lead here. Show your screen, and then we can get to the conversation.
Yeah, sure. As I do that. All right, let me get to slideshow. All right, can you all see my screen?
Yes, sir.
All right, so Khalil, I can give a very quick intro, just a little bit more of my background, and then I'll hand it back to you for, we can kind of walk through this as question and answer if you think that's the right way to do it. As Khalil said, I now look after a company called Privacy Chain, and I landed on Privacy Chain when I left Accenture for the second time a little over a year ago. I ran the North America Smart Products business for Accenture, which was fun for a while, and then as things happen in the consulting world, things change, and I decided to leave, and I landed up with Privacy Chain. And the reason I'm doing it is I think it is the most fascinating piece of technology I've seen in my very long career, during which I've done a lot of things. So I'm very excited for the opportunity to chat about what we're doing and think about how this might work in the healthcare world. So again, thank you for the opportunity, Khalil.
You're welcome, Andrew. We look forward to the great conversation today.
You want me to just kick off?
Yes, please. Please go ahead. You are sharing your screen, right?
I am sharing my screen. Hopefully everybody can see it. Can everybody see?
Yes, we can see it now.
Okay. So before I always, when I talk about this, although I'm going to talk about blockchain and I'm going to talk about cybersecurity, we are first and foremost going to talk about data, because that's what all this is about. And when we look at data generically across what's going on with enterprise, government, healthcare, there's too much data. It's coming too quickly, and it's coming from everywhere. And one of the things that we'll talk about further on is that this concept that data is stored as dumb data. And so all the intelligence sits around in the applications, the architectures, the tables that manage the data that is stored, but the data itself essentially is dumb. And that's the concept that we'll talk about a bit later. All of this means is that the right data is really difficult to find. And data security, you don't have to read what's going on very often to understand what a big issue data security is. And we'll talk a bit more about that. But the key issue in our world, we believe, is the idea that cybersecurity, whilst a very, let's say, maturing, growing, exciting industry, is primarily focused on what we consider to be perimeter-based defenses. And what we mean by that is protecting the outer walls, if you like, of all the enterprise infrastructure, be it hardware, software, networks, all that kind of stuff. But it's all based on the perimeter. And the security associated with data sitting behind that perimeter, in our view, lags behind. And once those perimeter defenses are breached, which happens way too often, the data is often very vulnerable. And so we'll talk about that. And then finally, the current approach to data is struggling in our view, and the current approach of top-down, trying to force our way through data management and MLM and all this kind of stuff, or master data management and all that is very difficult. It doesn't work in massive environments, and it's expensive. So that's sort of the background how we view data. I'm going to talk a little bit about specifically around healthcare, the electronic health record, because it's sort of top of mind for some of the conversations that we're having with potential clients and investors, and the idea that both within an organization and across organizations, the ability to rapidly, carefully bring together data from different sources about a patient or about groups of patients is extraordinarily difficult. And there's a lot of challenges, or a number of challenges that I've kind of listed out here that this has to deal with, that we have to address. So we'll talk a bit about this specific element of healthcare as well as we go through this. Whoops. So I'm not a healthcare expert. So forgive me if I've got this slightly, you may have a different opinion on this, but there's a tremendous amount of money being invested both by the enterprise, but also by the venture capital world in trying to solve these problems. Health data exchanges, health information exchanges. I'm aware of a number of startups that have received a significant amount of funding trying to build solutions to solve this problem, particularly across organizations and particularly in support of big pharma, as well as research and that kind of stuff. Again, our view is it's all top down. It comes back to this issue that data is dumb, so we have to build an infrastructure around it that enables it to be useful, secured, and shared in a meaningful way, in a safe way. And so what I call brute force, let's do more MDM, let's do more ETL, let's do more ELT, let's continue to do what we've been doing to try and solve ever bigger problems. So we're trying to do these things better and more simply without thinking about potentially different ways of doing it. I will mention Web3 once, maybe twice through this conversation. But if you think about Web3 as we do, which is essentially taking advantage of the decentralized processing power that sits in edge devices, as well as obviously smartphones, that's what Web3 should be from a technical standpoint, building applications, building solutions that take advantage of distributed processing power. The current structure of data management does not support that. And so when I say centralized, there's a long way to go in getting data to where it needs to be in the context of distributed processing power. And then I've talked about the perimeter-based security, and we see that, ever improving, but always focused on the perimeter. So briefly talking about blockchain, there are any number of companies, and very impressive companies, who are using blockchain and are bringing blockchain as a potential part of the solution to what's going on with this. And the idea behind it and what seems to be happening is that all of these companies are using blockchain as a single chain, whether they build it on Ethereum or they build their own private chain on some other standard, or they build their own standards-based chain. It's a single chain, and that limits the use of that blockchain very much to being able to record essentially transactions and things that are happening to the data itself. And yes, the blockchain gives you an immutable record of everything that's happened. Blockchains, in theory, are distributed, decentralized. And the idea behind blockchains, not just in healthcare, is that the blockchain gives you a trusted record of something that has happened. And there are any number of cross-industry use cases you could refer to about this, but that's essentially, a lot of these companies are doing really good stuff, but it's a view that's limited by the ability of blockchain to a single chain to acquire data, to record transactions, and to manage scale. So the actual data that's represented is often offline. It's often off-chain, typically is off-chain, and therefore it is, like any other data, vulnerable to everything that goes on with data that's not on chain. We also believe that there are going to be, although there are lots of activities or lots of initiatives to improve the scale of blockchain, it's extraordinarily difficult to do outside of relatively simple transactions. And then you can debate, frankly, whether blockchain is in fact private or whether it is the most public record of what's going on. Obviously, private chains are more private, but there's an interesting conversation going around blockchain. So blockchain is coming in to healthcare, no question about it. It's coming in a way that we think is certainly useful, but is limited by the constraints of a single blockchain. So I'm going to switch gears a little bit and start talking about privacy chain. And I will start this by saying we're not a blockchain company. And we're not a traditional data management company. We kind of reverse the way things work. And so I want you to think about how we store data and the implications of it. We store data, we secure data, we manage data at the individual record level. And so a record for us could be an X-ray. It could be a treatment record. It could be a pharmacy record. It could be a video. We don't care what data is, but we will take each record, and each one of those is an individual record, and imagine those records stored with their metadata and stored with an immutable history and chain of custody of everything that has happened to that record since inception. Right? And I'm gonna get to the how, but for now I'm trying to say here's what we do, and then we'll talk a little bit about why we think it's important, and then we'll briefly get to the how without going too deep. Now, I also talk about data that is self-aware, as opposed to what I started with up front, saying that data today is dumb. We store data in what we call a self-aware state because it's stored with its metadata, and that metadata can be exposed so that it can be found in real time in response to queries or actions, irrespective of where it comes from. We do no predefined data relationships and hierarchies or anything like that, because each record can be individually found in real time based upon the exposed metadata and the rules that are associated with each of those records, and we'll get to that. Each record is individually encrypted. And each record, the privacy rules can be set at the record level or any record or any level above that. So we can set privacy rules, data can be set at the source level, the group level, at the record level, and obviously data that is distributed is subject to the rules of the receiving entity, if you like. So each record is all of these things, and we store records anywhere. So records are stored where you want them to be. Your records don't have to be in a central database. You can store them where they're needed. And when a record is requested, it's presented in the response, in the format that is expected by the receiving system. So that's a lot. But essentially what we're saying here is that we store data, well, every data record, imagine what this means. Every record you have associated with patients or anything else is individually managed, individually stored where it's needed, individually encrypted, findable, and automatically privacy rules associated with it are enforced. That's what we do with data, right? And we think it's a very different approach to data and somewhat unique, but we think the implications are really interesting, and not just in healthcare, but let's try and keep this to healthcare. Right, so right off the bat, we can encrypt data at source. Our footprint, or the footprint that we need, is extraordinarily limited. So we could pick data up directly off a medical device, off an X-ray machine, directly off a physician mobile phone, if we needed to. So we can go end to end, and we pick up data at source, and we can encrypt it. We can start managing it immediately. The rules associated with the record never leave it. The record, the rules and the metadata and the history always stay with that record. And then from a security standpoint, if you refer back to what I said about perimeter, we sit behind the perimeter because we're securing at the record level. So if the perimeter is breached, then the records are individually secured. And so the analogy I use on the security front for health, for but let's say for healthcare, is that if a bank robber today manages to break into a bank vault, there's typically a pile of banknotes on the floor. With the privacy chain, that same bank robber would break into a bank vault and would essentially be faced by a wall of individually locked digital safety deposit boxes, each storing one banknote. Stolen data is not of any value to a hacker in our privacy chain world. Switching gears a bit, the fact that we're storing data in what we call the self-aware term, that means records can be assembled, can be found, assembled, and delivered in real time without any understanding of what the resource is or where it came from, because the exposed metadata is what essentially allows us to find these records irrespective of what the data record actually is itself. But the query defines what the requirements are for a record, and then the records are found. And there's all sorts of interesting tech behind that. And then I said we present records in the format that they are needed by the receiving system. We are, from a security standpoint, an at-home solution because we can secure data anywhere, as I said, so we can secure data at the record level on an individual's at-home device, mobile phone. They can work offline if the records are stored on their device. Records are accessible, although they're easily found, they are only accessible to authorized entities, individuals. So we set rules up at the record level, the data source level, but we also set rules up, obviously, for individuals and roles and people at the other end, or organizational. So we can define rules, but that match across what is the security or the privacy associated with the record, and does that individual who's requesting it meet those requirements? So we can manage in real time who has access to what records and do it at the record level. Same with privacy regulations. We can do the same thing. We set the rules up for the data, and we set the rules up at the receiving end. So if data is being sourced, let's say in the UK, we apply the UK regulations automatically based upon the source. There's a lot of interesting implications, but ultimately there's some really interesting efficiency improvements as well. We don't do ETL, and I'll get to that in a moment as to how that happens. We do no translation. We do very little MDM up front. And because we are a distributed architecture, we can use to store data and store clones of data anywhere in the infrastructure available to us. And most organizations, whether they are payers, providers, I don't care who they are, there's always excess infrastructure available that can be taken advantage of. We do a quick time check. How am I doing? Okay. Hopefully everyone's still there. So talking about taking it up one level to the idea of the health record issue that I raised up front, and this again is something that we've been talking about. We provide a safe sharing environment. And one of the things that I mentioned up front is the reluctance of participants to share data for obvious reasons. Providers compete with each other. There are all sorts of other reasons that people don't want to share data or only want to share bits of it. We provide that environment because we can set things up in a way that the participant can decide on a record or type of record what they want to share and what they don't. So proprietary detail can be hidden, private stuff can be hidden. And then each record, there's an immutable record of where it came from, who owns it, and every time it's ever accessed. So we believe that we can offer a very safe environment for data sharing inside and across organizations. The fact that we can encrypt at the record level means that we provide this additional behind the perimeter data defense, whether inside or across organizations. And there's some interesting conversations about a distributed architecture as well. A distributed architecture means that the centralized storage data vulnerability disappears. There's nothing for a hacker or ransomware to attack if there's no central data storage. But even without that, the fact that individual records are secured means that you've got an additional incremental level of storage of security across data that is being shared or stored somewhere. Data privacy is another area of great interest for us. We can get to the point of giving individuals control of their own data. And I won't dig into that because that's a ways out. And frankly, some of the conversations we've had on that issue, we don't believe many people want the burden of managing their own data. But we do allow the entities an increased level of control over the data that they have to store and secure and protect and share, because we can set those rules at any level and enforce them every time that there's an attempted access of the record itself. Same with regulations. It's the same basic thing. We can set those regulations dynamically depending on what data it is and from where it is being requested and all of those things that define at the record level what can and cannot be shared. An additional one is one of the issues that we've seen before, or maybe not so much in healthcare, but the idea of patients or individuals being able to benefit from the data they share. This would allow them to do that. Because again, we can set up a system whereby patients can even if they're not controlling their data, they can decide who has access to it and be rewarded if that's the business model being supported. And then I talked about there are, we believe, much easier ways to do what companies who are raising hundreds of millions of dollars are trying to do today. When you think about data as smart, self-aware data stored on a distributed architecture. So let me talk about how for a moment, right? This is a patent pending data management architecture. That essentially is what we're talking about here. As I said, we're not a blockchain company. We use blockchain, but we use blockchain only for storage of data. We do not use blockchain for any kind of transaction processing. So we don't run on Ethereum, we don't run on a crypto or token-based or coin-based blockchain. We run on a standards-based blockchain. With one exception, we don't do crypto processing. Now, can we run it on a crypto-based blockchain? Yes, we can. But the one our default is not crypto, but it is standards-based. But we can only do what we do because we're not doing processing on the blockchain. Blockchain for us is nothing more than a data storage mechanism. So what we do is every record is imported in its native format. So again, there's no ETLing. We store that data in a data object with all of its metadata. And some of that metadata will come with the record, some of it we can infer, some of it we can calculate. Each record is findable through to the metadata that we expose. There's metadata associated with the record that frankly falls, would fall subject to regulation. We don't expose that metadata because we can write the rules at that level to say, expose these fields, not those fields. Each record is then encrypted. Each record is stored with its privacy rules. And each data object that contains all of this data is then written to its own individual blockchain. And it's not a single blockchain. As I say at the bottom here, 1 million records is 1 million objects is 1 million individual blockchains. And what that allows us to do is store on a blockchain that contains a record everything that happens to it. So if somebody accesses and uses that piece of data or that record, and they are authorized to do so, that is a new block written to the blockchain that contains the record that has been accessed. And so the ability to create this individual smart record because it's stored with its metadata, findable through metadata, and there's an immutable history of everything that has happened to that record, we think is extraordinarily valuable in the context of being able to use data. And the fact that it is individually encrypted means that the level of security that we offer goes way beyond or extends beyond the sort of the perimeter-based defenses. But that's essentially how we do things. And as I said, we store everything in a distributed architecture, and there's various levels of abstraction and what we call DNS for data that allows us to know where records are. And then we can replicate data and use blockchain, the individual blockchains, to keep the records in sync. And that allows us to store records where they're needed. So we can clone records, and we can store records that are used regularly on a person's personal device. We'll have another copy or replica of those records that stays in sync on some central server if we need to, or somewhere else in the infrastructure. So we're able to replicate at the record level, which essentially means that we're doing backup at the record level as well. So if a device is compromised and we recognize it because there's an unauthorized attack or addition to a blockchain containing a record, we can shut that device off and rebuild it from records that are stored elsewhere in the ecosystem. Let me see where we're at. All right, this is a bit of an eye chart, but Khalil asked me to put something in here that kind of demonstrated how this works. So without going into all the details, this is actually a representation of an architecture that you will find online. I won't mention who it was, but it's a very well-known cloud provider. But on the left-hand side, we're bringing data in at the record level. And each record's imported in its native format. So there's no ETLing going on. In the column 2, moving left to right, are the rules that define two things. One is how we talk to the source system. So things like tables, type format structure, all of that falls into what we call a presentation rule. And then there are business rules, things like privacy, access, who has access to what should go onto it. And then we store the data across all the devices available to us, including remote devices, including all the devices that sit within the hospital, plus unused laptop and all that kind of stuff. All of that can be used to store data. Coming in from, so what you've essentially got is clones of the records distributed across the infrastructure of storage, all associated with rules that have been written on the left under column 2. If a query comes in, whether it's coming from web or coming from some other system, and that's over on the right-hand side, then let's say the query is requesting everything with tag 1. So privacy chain will find everything wherever it comes from that has that relevant tag through the exposed metadata. But then we will look at in column 5, are the rules, is the query able or allowed to or authorized to receive all the data requested? In my little example, point 6, is that the authorized rule, the authorization applies to S1, R1, C1, but not to E1. So the query will only get the records to which they are actually authorized to receive, even though record E1 meets the requirements or meets the criteria of the query. And that's essentially how it works. From an implementation standpoint, what the core platform is built. And so the way that it works with clients, and I'll talk a little bit more about this at the end, is that the things that you have to do is set up the connectors on both ends from source and destination systems, and then the business rules at both ends to determine how data is used, how it's managed, what it can be used for, by whom, and in what way. So that's essentially what has to be done in order to create this kind of environment. Again, looking at time, I think we're doing quite well. So just coming back into healthcare for a moment, and I realize that this is a lot of data information and probably sounds like gobbledygook to you because it's just so unique, at least in our perspective. But hopefully there'll be time for questions at the end of this that I can answer. But broadly at the healthcare level, we think there are opportunities within the single organization. I don't know how many different systems there are that sit within, let's say, a provider or perhaps a payer organization, and that data has to be rapidly aggregated to support a patient for whatever reason. So we think there's value there because of the ability to find data and aggregate it in real time just for a particular patient or a particular issue or whatever it might be. I talked about the idea of going end to end and being able to pick data up from devices immediately. I won't dive into this, but we can actually go down to an SoC level and pick up data from system on a chip if we needed to. But the idea of being able to pick up an X-ray immediately, secure it, and then make it accessible immediately subject to authorization, we think is potentially of value, particularly in sort of fast-moving environments where data is a key source of value. The example, the medical device, the 3D printer is another one. I doubt, or maybe I'm wrong, that I don't know how far 3D printing has got into the world of healthcare, but one of the issues that I know prevents organizations from using 3D printers in critical situations is the veracity of the data that is sent to that printer. How does anybody know whether the data field or the data file that gets to the printer to be printed has not been tampered with, and so forth? And so in that direction, we can deliver that encrypted file into that device and keep it there and keep it encrypted. So there's the edge component of what we do, we think is of value. And then, as I mentioned before, just the management and security of data within the organization. I was looking at the level of healthcare data breaches, and it's astonishing to me. Somewhere I read, and I should have kept a record of this, that healthcare was one of the, if not the most often attacked industries, if you like, in context of data attacks and data breaches. And the numbers are off the chart. So recognizing that data security by itself is not necessarily an interesting sale, but it's certainly something that we think is of value, particularly in the context of some of the other stuff that our approach to data allows us. And I try not to be too salesy here. I talked about the multi-organization stuff. We think the issue of a secure, safe sharing environment that's sufficient and effective is potentially of interest. And the one use case I haven't talked about at all yet, I'll mention it briefly in a moment, is the idea of monetization of research. So a research paper for us is just another piece of data. And we can secure that research paper and set it up in such a way that if somebody buys it, it cannot be shared. It cannot be distributed because there's only one key to it, and that is distributed to the owner of the data itself. I'm trying to wrap it up in the next few minutes. I wanted to talk about this very, very briefly because I also wanted to take a step back and talk about the versatility of what we're doing with data. Evergreen NFT is our first product to market, and it's focused on digital assets and content rights management. And anybody who's been following the non-fungible token world with any depth will know that there are two sides to that argument. Aren't NFTs wonderful? And on the other hand, aren't NFTs essentially a bit of a Ponzi scheme because the values in the token and the underlying art has no value at all because it's copyable and all of that. So we're going into that market and because there's a tremendous amount of hype, but there's a tremendous amount of value that we can deliver creators because their creations, again, are nothing more than another piece of data. So we can store a video file that somebody creates, write the smart contracts that define how it can be used, who it can be sold to, as well as the commercial terms. And when somebody buys it, we can provide the owner or the buyer with exclusive access to the artwork that underpins what they've, maybe the NFT that they've actually bought. So I bring this up because it essentially brings the idea of physical ownership, physical control into the NFT, into the digital world. And it's way broader than art and all that, and entertainment, but I bring it up because it's another indicator of perhaps the breadth of use cases that we could consider in healthcare and beyond. And I think, what do we got left? So yeah, let me take a step back. We're very excited by working with Khalil and Hari because our approach, frankly, is to work with leading organizations like Saxon. We're not a services company, we're a licensing company. Our approach is to find organizations and Saxon who really understand the industries within which they work and have the skills and the capabilities that we don't want to have, to really take and make use of this data for their this approach data with their clients. And the way that we think about this in context of clients, particularly as this is a very new and different way of thinking at data, is our approach that we're sort of working through is proof of concept, or what I call a proof of value. And then a sort of a parallel approach to scaling it into kind of a pilot before anybody gets to broad implementation. But to do that, we would partner with Saxon to walk a client through the process. And again, we're very excited to do that. On the right-hand side, very briefly, what's interesting, one of the interesting and one of the things that got me to go from a company of 500,000 to a much smaller company is that I actually first met my co-founder 20 years ago when he built the first iteration of essentially this distributed architecture. And it's interesting, I ran an Accenture team that was helping them try to commercialize it. And a lot of the materials and the messages were exactly the same as they are today. It's individual record security, it's individual record accessibility, all those kind of distributed architecture. So the foundational architecture is well proven. Blockchain was the game changer because it allowed us a level of data security and data storage we didn't have before. But the way I describe this is that the architecture is mature and well proven. This particular iteration and going to market in this particular environment is less mature. And that's why we're building through and working with people like Saxon. And I think, let me hand that back to, I have an appendix. Let me go through all of that. Hari, let me pass this back to you, or Khalil, let me pass this back to you. I think I wrapped up and this is back to you.
Yeah. Thank you, Andrew. Thank you for a great presentation. And I want to thank all the attendees for listening in. I want to take some time out and see if anybody has any questions. Mark, anybody else? Do you have any questions at this point in time that we can answer as a team?
Let me stop sharing.
Anybody?
So, Andrew, thank you once again for the great presentation. Just wanted to kind of, I know we took today probably healthcare as one of the industry where probably privacy chain has good use case to solve. And we have discussed in the past to our discussions that it is not limited to healthcare as an industry. And you have also highlighted that anywhere we are looking at data management or data security as an issue, it need not be limited to one industry. So to that extent, what are some of the other use cases that you are seeing? You already touched upon the NFT world, but if it comes to the more traditional industries, when we talk about the financial services, which also has a lot of data issues, or for example, the e-commerce industry, which also deals with a lot of personal data or any of those things. Are you seeing any applications or
Yeah, definitely. Obviously, where there's PII data involved, the whole question of data security becomes a big issue. And the challenge with, and if you think beyond, but even financial services and consumer-facing brands, the value or the brand impact when data is stolen, particularly consumer data, is almost immeasurable. So just from the pure data security components, we offer that additional level of not breach prevention, but risk mitigation and loss mitigation. So there's definitely value where there's PII involved. Financial services is an interesting one, and I put legal into the same bat. One of the issues that I'm aware of is contract. Is essentially contract immutability, to use that word. That although people like DocuSign and companies like that enable the tracking of e-signatures and all of that is recorded, the actual creation of that underlying contract, who started it, who edited it, who accepted what edits, who accessed it, who read it, and so that entire chain of custody is something that is often lacking and often causes issues at the end, particularly when, heaven forbid, there are legal issues associated with a contract. Judges sit and say, well, tell us who did this and tell us who added that piece, and nobody can answer it. So because we can store right from the moment of inception that contract in its own object, on its own blockchain, and we can record as new blocks on that blockchain everything that happens to it, including things like edits that are rejected. So if there's a single owner and requesting edits, the whole action of accepting edits or requesting edits can be recorded as a new block on that blockchain. So you have an immutable history of everything that happened to that contract outside of what's going on today, which is essentially signatures. And we think certainly in financial services and legal, those are very interesting use cases that have come up. Financial services in particular as well, the whole idea of research papers and research and the protection of research is an issue that we haven't looked into, but we've looked at it in the context of Gartner, for example. And that's the illegal sharing. Somebody buys it and then shares it. And it's not difficult to do if you have any tech savvy, but if you do it, if you wrap the actual research paper itself in a blockchain, issue one key, then you make it a whole lot more difficult for people to share, illegally share, or contravene licenses associated with what they bought. So that use case has also come up in the context of legal and financial services. I mean, just you didn't know, but a couple of other industries that are very interesting or top of mind have been industrial infrastructure. I'll just use the Colonial Pipeline example as an example of the difference. So a single leaked credential of an employee who'd left the company, I think it was a VPN credential, something like that, allowed the ransomware to penetrate. And it sat there, and then I can't remember the stats, but over a couple of hours, one central data storage had been reached. They stole a tremendous number of records from the central data storage, all of which was individually unencrypted, and then obviously they encrypted everything themselves. So there was no behind the perimeter protection in the case of Colonial Pipeline. With the privacy chain backend storing that data, the stolen credential would only have had access to the data that credential was authorized to see. And so the ability to lock data down in the event of a breach, because you can secure it at the record level and you can set controls at that level, we think is really, really valuable in the context of infrastructure, government, vulnerable facilities, and all that kind of stuff. Government for us, though, is a very challenging market for all the reasons that you guys probably understand. We're not equipped to go through the whole government process and all of that. So like everything else, we're looking for partners to do that. But yeah, we think it's very unique in that world too.
Andrew, for the purpose of audience, we talked about POCs versus pilot versus implementation. If you take clinical data set around Patient 360, right? There's a lot of data that has to be coming from multiple distributed systems within the healthcare space. What do you think that use case will take in terms of POC versus pilot versus implementation from a timeline perspective based on privacy chain insights?
Yeah, I'm a consultant, right? Well, I was a consultant, so it depends. No, so if you think about what drives the length of time and the resource level, it's essentially the number of the number and complexity of data sources. So if you want us to pick up and start using 10 data sources, then there's a level of time associated with that as opposed to 3. Mm-hmm. We would expect to work on a pilot to work with an existing destination. Let's say it's some kind of reporting cube or whatever it is. So that element, we'd need to build the connector, but that's a relatively simple thing to do. The other thing that drives complexity is the associated rules, the rules associated with the data. What complexity do you want to drive? And what do you want to demonstrate? I mean, demonstrating the simple ability to secure records and secure records in a way that means that you, Khalil, have access to them and Shiva does not. And, you know, Vaibhav can actually write, and that's relatively simple to do. But the more complex the rules and the privacy and automated application of EU regulations would take longer. So it does depend, but those are the things that it depends upon. But my gut says, based upon other conversations we've had, that something relatively simple with a couple of data sources, some relatively simple rules that prove some basic fundamentals of what we're talking about without getting too complex, and a relatively simple backend, 8 weeks, 8 to 10 weeks, 8 to 12 weeks. And I can hear my co-founder in the background swearing at me when I say that, but that's not beyond the realms of possibilities for a reasonably thorough proof of value or proof of concept. You know, and pilot beyond that, it runs from there. And again, we recommend, or we would recommend, moving from a proof of concept into something that's that you can essentially run in parallel, so that you get the extra, you know, a client can get the extra, or a customer can get the extra level of, this is so different, I really want to see how it compares to what I'm doing today. Completely recognize that. And so the pilot we would recommend is something, again, reasonably simple but meaningful, but that you can actually validate the results of. And the way that we would see that happening is in parallel. But, you know, if a POC, if we're building off the POC and the POC is not a throwaway, then you're probably adding a couple of months on to get further on. An implementation, who knows? You know, that completely depends upon the breadth and extent. Hopefully that, hopefully that helps a little bit in the context of scale. This is not we go away for a year and then come back with some crazy solution. This is a very, very iterative process, because we have to sit and work with you guys and obviously the customers we need to understand and what the data needs to do, so that we can write the appropriate rules and then work with them so that they can see what's going on.
Got it. And Andrew, second part of that question, for the purpose of the attendees here, connectivity. You are totally source agnostic, right? Any EHR system, pharma system. So can you talk, for the purpose of the audience inside, how seamless it is to connect to any sources where you are applying the privacy chain?
Yeah, I'm going to try. I'm not the technical guy, as you know, but let me try and explain it. So the answer is yes, we're completely source agnostic. Obviously, the content has to be in some digital format, so we're not going to be able to take in handwritten notes. That needs to happen before it gets to us, and I know that's an issue in healthcare. But what it takes is we essentially build a single connector. There's no source to source. There's no sort of spaghetti connections here. Everything talks to privacy chain. So there's one connector for every source system. And essentially what that connector does is help us understand the context of the data, the formatting. Although we store in the native code, or the native, we do no ETLing, we have to build the connector to understand how to talk to that particular source system. So all the context, potentially libraries, formats, all of that gets built into the connector, so we know what we're getting, and have built the connector to handle it. But everything talks to privacy chain. So if you just think about, I'm pulling data in from an EHR system and I'm sending it to an ERP system, maybe a bad example, we take the data through the connector from the EHR into privacy chain. We do everything we do here. And then the delivery, we automatically, through that connector, display the information requested in the format that the ERP system demands. So there's a connector privacy chain, connector privacy chain. We're not doing connect from EHR to ERP, because that is what happens today to a large degree, and it's massively inefficient.
Got it. And
One of the
I want
things one of the really important thing I'll say to that, just if something changes in the source system and you've got the spaghetti, then everything breaks. With us, all we need to do is update the connector to that source system, and then everything else just carries on. So it's a very much more efficient way, we think, of handling what you could call master data management.
And this is a custom connector, like from let's pick any EHR system, let's say Epic, right? So Epic has its own set of APIs and others. So on your side, are you building a custom connector to ingest these APIs for whatever patient records are?
It depends how you so what's custom about what we do is the architecture. The tech stack is entirely standard. There's nothing custom in the technologies we're using. The way that we manage distribution, manage data, and all that kind of stuff, and the object formats and all of that, that is what we call custom. So the connector itself, it's going to be standard technologies that leverage everything. There's nothing unique about that from the point of view of the technologies being used, and whatever the API is will match it. But is it a single connector for that Epic? Then yes, it is. It's a single connector for Epic, and it could be a single connector for that particular version of Epic. Because I know that Epic doesn't necessarily talk to Epic, so I hear. Maybe that's not true if anybody's from Epic, but I've heard that. But it's a single connector specifically for the source system, and but the underlying technology stack we're using is standard.
Got it. I want to ask again, audience, if you have any questions, please, we'll have another 4 minutes into the conversation. So anybody has a question, comment, please share now.
I have a horrible feeling I've shocked everybody into disbelief or something.
Hari, do we have a list of questions from the audience?
I don't see any questions coming up in the chat window. I think we are good there.
Okay. I see Ed. Ed, do you have any questions? A comment?
Yeah, I was interested in, are there any special considerations around the cloud interaction or the foundations you might have in the cloud around this? And then also coming out of my last gig where we were talking to Salesforce and Workday and things like that, and trying to integrate into Stack. I assume that, on the left-hand side of Andrew's chart, those interfaces and things would work as well with those applications. Because it's in my interim work where you got Salesforce and Workday involved, and you need to protect that type of data as well.
Yes, it's less a question, and good to see you again. It's less a question of the technology answer, and more a question of what hoops do we have to jump through to work with those guys. I mean, we are actually shifting our backend onto AWS. Actually, we just have shifted our backend onto AWS for now as we start to build out the scale. But it's much more of, what do you want us to do this? Particularly as it's somewhat unique.
Yeah.
So it's, yeah.
All right, thank you.
Thank you, Ed. Mark, do you have any questions or comment? Okay, all right. So thank you, everyone. Truly appreciate the—
Neil, I have a question. Sorry, I was talking on mute.
Yeah, go ahead.
So Andrew, since we're talking about the use cases, right, of the policy chain, so, what was that one challenge which came across, right? Like you thought, okay, this can be also perceived or, could be going into this direction. It can be any vertical or, any domain. But what was that, made you perceive through it when you're executing, or, when someone came up to you that, how can be this done kind of a thing?
So what was behind all of this?
Yeah.
Is that the question?
No. So basically, for example, I come to you saying that, hey, this is my challenge, right?
Oh, okay.
And then someone says, and then you say, you can do privacy chain. And then the other person is taken away saying that, hey, why? is there any other approach, or is this the only way to go ahead?
It's typically it's not a privacy chain and nothing else type approach to this. Certainly, if you think about this from the point of view of, let's say, the user experience, let's take an existing infrastructure where I've got people on one system and people on the other system.
Correct.
The user experience doesn't change.
Right.
Typically, right? Because it's like you go online and you search something on Google. You don't care how it got to you. Or you click save file on your laptop and it saves magically and then it's done.
Yeah.
You don't really care how it happened. So the user experience doesn't change.
Right.
The change sits in the back end, and we can sit way in the back end because we're essentially the last line of data storage, if you like. So can I apply this approach to data storage on an Oracle database? Theoretically, I could, but how difficult would that be? So we're a sort of, in that sense, we're almost an alternative and a much cheaper alternative, I will tell you, than Oracle. And I'm not picking on Oracle, but that's where the difference starts. In the context of the user experience, all the interfaces, the applications, there's no change. All we're doing essentially is saying, instead of storing to Oracle and getting data from Oracle, store to privacy chain and get data from privacy chain. That is the difference, essentially, technologically. Does that help? Does that answer the question?
Yeah, that answers the question. Thank you.
Okay. No, thank you. Good question.
Appreciate it.
Again, we ran out of time, so thank you, everyone. Truly appreciate it. Andrew, great presentation. And thank you again, guys. Appreciate it.
Thank you so much, everybody. I hope I didn't get. I never know how to take no questions, but I appreciate you guys staying on, and thank you for the opportunity, Khalil. And I really enjoyed it. I love what we're talking about here, and so thank you very much. And have a great day.
Thank you
so much.